Welcome, honors. So this is legitimately my favorite section, and which I love this section so much, but it also kind of makes me sad that I'm doing this through a video. So I know I'm like a super nerd on so many levels, but when you guys get into pre-calc and you guys are doing this section, please, please, please come back and ask me for help. Even if you don't need it, just come back and ask me for help because I enjoy it so much. It's like a puzzle for me, and I think that it's so fun and it's so nerdy, and I accept it and I realize it, but it is what it is. So okay, what I want you guys to do, have a printer, great, you can print this out. If you don't have a printer, that's fine too. Take a minute, just copy down whatever, you don't need you can format it however you want. These are, your notes at this point. But this is 6-2. I know we're going backwards, but this is 6-2, trigonometric identities. So a trigonometric identity is an equation involving trigonometric functions that is true for all values. That should be values for which every expression in the equation is defined. The identities help to evaluate functions, simplify expressions, prove identities, and solve equations. So we're doing super basic ones this year, and then you're going to you up the ante a lot, next year. And that's when they get super fun. So, yep, I'm a super nerd and I get it and I accept it, but that's fine. Okay, so first is your reciprocal identities. So your reciprocal identities, we've been talking about those, you know those. So your reciprocal identities, the sine of theta is the same as 1 over cosecant theta. And then the reciprocal of cosine, 1 over secant theta, and then tangent theta is 1 over cotangent theta. And then cosecant, secant, and cotangent. So cosecant is the reciprocal, so it would just be 1 over sine theta, which if you know these, right? So then this would be 1 over cosine theta. And then this one would be 1 over tangent theta. So we've already been dealing with those. Those are something that you guys have already seen. Now for the next one, for the quotient identities, I'm going to actually show you where this comes from. So tangent theta. Well, we know in a triangle, let's draw a triangle. Say we're looking at this angle. We know that, okay, tangent is opposite over adjacent. Now, in our, let me break that actually to the side here. So we know that tangent theta is equal to opposite over adjacent. Well, the adjacent is always our x value, right? When we're looking at our graph. And our x value always corresponds, zoom out here, always corresponds with cosine theta, right? That's always been, x is our cosine theta. And then up is our y value. It's r, and our y value relates to sine theta. So if tangent is opposite over adjacent, and adjacent is relating to cosine, and sine is relating to the opposite, then tangent is going to be the same as sine theta over cosine theta. And so that's actually the quotient identity. So I'm going to zoom back in. And this is probably one of the ones that you're going to see over and over and over and over and over and over. So tangent theta is equal to sine theta over cosine theta. And then cotangent, we know cotangent is the reciprocal of tangent. So if it's the reciprocal of sine over cosine, cotangent is cosine theta over sine theta. Now, how I have remembered that is cotangent has the cosine on top. And tangent, I don't know, I just like remember the cotangent one. So, but I've also just memorized it. So the Pythagorean identity, we're actually going to come back to here. And we're still going to actually use this exact same setup here. So we know in the unit circle that the radius or the hypotenuse is 1. And the Pythagorean theorem we know is a leg squared plus a leg squared equals the hypotenuse squared. So going kind of on that notion, that would be, okay, so that would be a leg squared. So it would be cosine theta squared plus another leg squared, sine theta squared equals 1 squared. Well, we know 1 squared is just 1. And we know, okay, cosine theta squared, that's not how we write it. Remember, you write it as cosine squared theta, and then you write this one as sine squared theta. And so that is the Pythagorean identity. And that's another huge one. And we use that like so much. It's super important. And there's a lot of space there because there's different versions of it. So sine squared theta plus cosine squared theta is 1. Now, we can also manipulate this. And I'm going to show you on the whiteboard how you can manipulate it. So I don't write these on the actual, like on our notes because you can write them on the side if you want, but like I figure you guys can all kind of like manipulate them all in your head. So like what I mean by manipulate them is if we have, so if we have sine squared theta plus cosine squared theta, I know you can't see that. Equals 1, then you can rewrite this and it still be the same equation. So I could subtract sine squared theta from both sides, and I would have cosine squared theta equals 1 minus sine squared theta. And we use that a lot. We use like the manipulation of a lot. I could subtract cosine squared theta, and I have sine squared theta equals 1 minus cosine squared theta. So it's just kind of like rearranging the same thing, which is why I don't write the other ones down. Now, what I do write down and why there is so much space is because we're going to look at what would happen if we took the original one, sine squared theta plus cosine squared theta equals 1. And what if I divided everything through? Remember, we have to divide like an equation by every single part for it to be the same thing. What if I divided everything through by sine squared theta? Oops. So, okay, sine squared theta over sine squared theta is 1. Cosine squared theta over sine squared theta, well, we just wrote that. Cosine over sine is cotangent. And so this becomes cotangent squared theta. And then 1 over sine squared theta, well, we know 1 over sine squared theta is the reciprocal, so it's cosecant squared theta. And I can, again, like rewrite this many ways. So I could get 1 by itself, and I could have it be 1 is equal to cosecant squared theta minus cotangent squared theta. You can get it. So cotangent squared theta is by itself. So cotangent squared theta equals cosecant squared theta minus 1. So all of those are essentially the same as this one right here. But we're just going to write that one down for our notes, and then, just know that you can manipulate them. So that one is going to be 1 plus cotangent squared theta equals cosecant squared theta. And if you're wondering, like, in the future, where in the world did that come from? It's just, this is all terms divided by sine theta to get here. Now, if you're thinking, oh, there's still a lot of space there, well, you're right. There's still a lot of space there because we're going to do the same thing, but instead of dividing by sine, we're going to divide by cosine. Okay, so I'm going to erase all this. This whiteboard is not the same as the whiteboard at my house, my house, sadly. Yes, the school is my house. At school. Oh, apparently I pulled over. Look, you guys can see my to-do list. Okay, so we divide everything through by cosine squared theta. Cosine squared theta and cosine squared theta. Well, sine over cosine, what do we know that sine over cosine is the same as? We just talked about it. Sine over cosine squared would get me tangent squared theta. And then cosine squared over cosine, anything over itself is 1. And then 1 over cosine squared is secant squared theta. So again, you can manipulate that any way that you want. It can be, 1 equals secant squared theta minus tangent squared theta. You see that one, like that manipulation a lot. Or you could get tangent by itself, and that's equal to secant squared theta minus 1. But like the last one, we're just going to use this up here. Okay, so we're going to write that down in our notes. And so that's going to be tangent squared theta plus 1 equals secant squared theta. And so this, I'll zoom back in. This one is all of my terms divided by cosine. Okay, so those are your Pythagorean identities, and just kind of reiterating. So you will have to, for honors pre-calc, you'll have to have these memorized. So really what I have memorized is obviously I know my reciprocal identities. I know that cosecant and secant and cotangent are which ones they match with. I know my quotient. I have those memorized. And I know both of these, but really if you just know tangent and you already know this, then you can get to this. And then my Pythagorean identities, to be completely honest, I only have this one memorized, but I know how to get these two. I will write this one first. If I was doing a problem, I would write this one down first. And then I would, using what I know from everything up above, I would come up with these two on my own. So that's kind of where I would go with memorizing. But if you want to memorize every single thing, that's totally fine too. Make flashcards, do a Quizlet or whatever. Okay, so complementary angles theorem. Now, I'm going to write down what it is, and then I'm going to explain it in a second. So sine theta is always going to be equal to the cosine of the complement. Remember, a complementary angle is a 90-degree angle, is where two angles add up to be 90 degrees. So the sine of, let's say, 40 is going to be equal to the cosine of 50. The cosine of theta is going to be equal to the complement of sine, which makes sense. Those go hand in hand, right? So that's saying like the cosine of 40 is going to be equal to the sine of 50. Tangent theta, tangent goes with cotangent. So 90 minus the angle. So like tangent of 40 would be equal to cotangent of 50. And then cotangent goes with tangent. Cosecant goes with secant. And then secant, of course, goes with cosecant. So if you guys go into, like, if you want to look back, but I'm going to look back for you. If you guys look back into notes when we were together and in class, we did this page here. And we looked at 30, 60, 90 triangles, and we did all that. Now, what that complementary angles theorem was saying was the complement of sine is going to be equal, like the complement of whatever angle you have for sine is going to be the same as cosine. So the complement of 30 would be 60, right? Because 30 plus 60 is 90. So sine of 30 should be equal to cosine of 60, which it does. And vice versa. The cosine of 30 should be equal to the sine of 60, which it does. And then the tangent of 30 should be equal to the cotangent of 60 and vice versa. Cotangent of 30 should be equal to the tangent of 60. And then the cosecant of 30 should be equal to the secant of 60, which it is, and vice versa. The reason why this works is because if we're dealing with a right angle, we know that like in a triangle, it always adds up to 180. So if one of the angles is already 90, these two, no matter what, are going to be complements of each other. And in like trig, what changes is the like opposite and adjacent when you're changing your angle. And so how those change is like the opposite and adjacent always switch. And so that's why like sine matches up with cosine, is because the like opposite and the adjacent flipped there. So instead of it being opposite over hypotenuse, it's now looking at adjacent over hypotenuse. So that's kind of what the complementary angles theorem is saying. And it is something that's super important. We use it a lot. So here are some of my like hints to simplifying trigonometric expressions. And this goes like the long haul. Like we really do, like I still follow this when I'm doing like the more challenging problems. But the first thing I do is I always make sure I have the same angle measure. Now, for us to do that, like the only theorem we have to use with that is the complementary angles theorem. And you're going to often see me refer to that as CAT, because I will shorten it. But we use the complementary angles theorem to do this. So the next thing, that's always kind of like in like this is the order I do things in as well. So if you guys like see here, you know, when we're simplifying an expression, we first make sure they have the same angle measure, which they do, like these already do. When the trig functions are squared, so like here, trig functions are squared, use the Pythagorean identities. So like that should always be like a big hint. Whenever you see anything squared, you should instinctively think, I've got to go to my Pythagorean identities and use those to help me. So for cosecant and secant, whenever you guys see cosecant and secant, instead of writing these as cosecant and secant, change them in terms like to sine and cosine. So you're going to change cosecant, you'd rewrite it as 1 over sine, and secant, you'd write it as 1 over cosine by using fractions. So remember these are just your reciprocal identities. And then for tangent and cotangent, change to sine and cosine using the quotient identities. Oops. So for tangent, write it as sine over cosine, and for cotangent, write it as cosine over sine. Okay, so we're going to get into a lot of examples here. Some of you guys will really catch on to this really quickly. Some of you guys will need a lot more time with it. That's fine. We have 12 examples to get through. So here we go. Okay, so our first one, we look to see, do they both have the same angle measure? And they do. Then the next thing I think about, so that's good. Step 1's good. So the next thing I want to think about is, are they squared? And they are. There's sine squared 70 plus cosine squared 70. Now, because they are the same thing, that tells me, what did sine squared theta plus cosine squared theta equal? Well, if you're saying 1, you're correct. And so what this entire thing actually simplifies to be is 1. I know, crazy, right? That's why I like these. So we used the Pythagorean identity here. Of sine squared theta plus cosine squared theta to help us. And so that's how I got that one to be 1. Okay. Now, again, like I know I've said this before, but I really encourage you guys as we go through these, make sure like wherever you're confused, like something doesn't make sense, write a note to yourself and then bring them to office hours. You can always, like if it's urgent, you can shoot me an email and ask me there. But office hours is a great place for you guys to get the help that you need. Okay, so tangent 70 and cotangent 70. So first thing, are they the same angle measure? And they are. So we're good there. We can look at the next hint. It says, when the trig functions are squared, use the Pythagorean identities. Well, neither one are squared, so we can't do anything. And then it says for cosecant and secant, well, these aren't cosecant and secant, but these are tangent and cotangent. So if you think you know where to go with this one, what I want you guys to do is pause me and see if you get to the correct answer. If you're like, I have no idea where I should start, that's fine. We'll do this one together. So tangent 70, we know tangent is sine over cosine. So we're going to rewrite this in terms of sine and cosine. So it's going to be sine 70 over cosine 70. We just keep the angle measure there. And then cotangent, we're going to write in terms of sine and cosine. So that's going to be cosine 70 over sine 70. Well, what do you guys notice happens? What happens with the sine 70? Sine 70 is on top and it's on bottom, so it cancels out to be 1. Remember, when anything like cancels on top and bottom, that cancels to be 1. Well, the cosine 70 and the cosine 70 also cancel out to be 1. And so we're left with my final answer of 1. Okay, so this one we use the quotient identities to help us. Now, let me explain, like you guys don't have to write, your steps and your thought process. I will be doing that so you guys can kind of see like how I'm getting from step to step. But yeah, so that's like kind of how I'm trying to explain my thoughts there. Okay, so let's look at 3. It says tangent 12 minus cotangent 78. So first, are those angle measures the same? And you should be saying no. And then we should be thinking, what's 78 plus 12? Well, 78 plus 12 is 90. So those are complements of each other. So that's the first thing we want to do, and we're going to be using our complementary angles theorem. So the first thing we want to do is get the angle measures to be equal. So first, get angle measures to be equal. And so we're going to be doing that using the complement. Now I can change either tan 12 or I can change cotangent 78. I'm just going to go ahead. I usually would ask you guys what you want to do, but I'm going to go ahead and just change the 12. If you changed this one, you would get to the exact same spot. And I can actually show you that too. So let's say we picked 12. We know that 90 minus 12 is 78. And so remember, the complement of tangent, if you guys look back up at your notes, the complement of tangent is cotangent. So we can rewrite tangent of 12 as cotangent of 78. Okay, and then bring that one down. And now they have the same angle measures. Well, what's cotangent 78 minus cotangent 78? Anything minus itself is 0. That's so fun. I know. Okay, so we use that. This one was applying the complementary angles theorem, and that's how we got to our final answer. Okay, so again, if you guys have any questions, pause it, write down something on a note, come to office hours, send me an email, whatever you guys want to do. Okay, so number 4. Number 4 says 1 plus tangent squared 5 minus cosecant squared 85. What I want you guys to do is pause me right here, and I want you guys to think to yourself, what's the first step that we're going to do here? So pause, think about what's the first step, look at the hints to help you, and then come back. So at this point, you should have already thought like, okay, what's my first step? And if your first step was to get the same angle measure, then you would be correct. And I actually didn't show you, even though I told you I was. So this one would have been the same, like we would have changed this one to tangent of 12, and then tangent 12 minus tangent 12 is 0. So you guys could have either on this one noticed, okay, 5 and 85 is 90. And so you could have either changed 5 or you could have changed 85. I'm going to change the 5. And so we know, okay, first, the complement of 5 is 85. And so I can rewrite this instead of tangent squared 5, I can write it as its complement. So it would be 1 plus cotangent, because we're using the complement of 85, minus cosecant squared 85. So I didn't change anything except this one right here. And so again, I used the complementary angles theorem there. Okay, so now I have the same angle measures. My next thought is, I see some squareds there. So I look at my Pythagorean identities. I have sine squared theta plus cosine squared theta. I have 1 plus cotangent squared theta, and then I have tangent squared plus 1 tangent squared plus 1. So I think, well, I'm going to use that 1 plus cotangent squared 80, like theta. And I can apply that here. Well, 1 plus cotangent squared theta is equal to cosecant squared theta. So 1 plus cotangent squared 85 is going to be equal to cosecant squared 85. And then this just is brought down. So again, I applied my Pythagorean identities here. Okay, so then cosecant squared 85 minus cosecant squared 85, well, 0. And that is that for number 4. You could have changed cosecant squared theta to secant squared 5, and you still would have gotten to the same place. So you would have been able to use tangent squared theta plus 1 and like converted that. So you still get to the same thing there. Okay, I'm going to continue on with my identities. I know this is a lot, but I think the more practice you guys get with these, the better you are. So it just helps to like get that, the more exposure, the better here. Okay, so cotangent 25, cosecant 65, and sine of 25. So first, I recognize that they are not the same angle measure. So what I want you guys to do is pause me here. I want you guys to try this one on your own, see how much of it you can do, and then come back and check your work. So pause here, come back, check to see how you're doing with the problem. Okay, so you should have kind of like gotten through some of it or all of it, hopefully. But if not, so I would have changed cosecant 65 because all the others are 25. So why change 2 when you only have to change 1? And we know, okay, we're just going to double check. Does 90 minus 65 get me 25? And it does, thank goodness. And so I start by just changing that one. So cotangent 25 is going to stay the same. Cosecant 65 is going to become secant because it's the complement 25 times sine 25. Okay, there's no squared, so we're not using the Pythagorean identities at all. But there is a cotangent and a secant. And so I want to write those in terms of sine and cosine. So cotangent we know is cosine over sine. So I'm just rewriting cotangent as cosine over sine, which I should have explained this step. This step was the complementary angles theorem, and now we're going to be using 2 actually. And then secant we know is 1 over cosine. And then sine, we're just going to keep as is, but I'm going to put it over 1 because everything else was a fraction. And so to get from here to here, I used my quotient and reciprocal identities. Okay. So then I look and I'm like, wait, I can cancel a lot of stuff, which I love. You guys know that. So cosine 25 and cosine 25 cancel to be 1. Sine 25 and sine 25 cancel to be 1. And so everything is canceled. I'm left with 1. That's the best. Such a good feeling. Okay, so on 6, I want you guys to pause me here. Try that one on your own. Do as best as you can, and then come back and check your work. So you guys should be coming back to check your work. First thing I notice, okay, my angle measures are the same. Great, and nothing is squared. Cool. So what I go in is to changing everything in terms of sine and cosine. Well, cotangent 50 is the same as cosine 50 over sine 50. And then we have cosine 50 over sine 50. Well, what's anything minus itself? 0. So all I did was I used the quotient identity here. Now let's say you instead converted cosine over sine to be cotangent 50. That's fine too. So either way gets you to the same thing. Okay, so what I want you guys to do is I want you guys to pause here, try 7 on your own, see what you can do there, and then come back and check your work. Okay, so hopefully you were able to kind of get through that one. And hopefully the first step you noticed was you wanted to convert these so they were the same angle measure. So cosine of 50, I'm just going to take a stab and say that the first one was the one that you changed. So we just, always make sure 90 minus 50, does that get me 40? And it does. So I'm going to rewrite cosine of 50 using its complementary angles theorem, so sine of 40. If you changed cosecant of 40, that's totally fine too. So we use the complementary angles theorem. Okay, so then I want to always change cosecant or secant, one of those, into terms of sine and cosine. So I'm going to keep sine of 40 the same, but I'm going to rewrite cosecant as 1 over sine of 40. Well, and hopefully you notice what's happening here. Sine of 40 and sine of 40 is going to cancel, and I'm left with 1. These have a common theme, I know. So this one we use the reciprocal identity. Okay, so 8. 8s are, again, pause it. I want you guys to try this one on your own, see how much you guys can do, and then come back and check your work. Okay, so you should have kind of hopefully gotten through the whole thing. This one's pretty straightforward. Let's say we changed the first one because we first recognized 42 and 48 are not the same angle measure, so we have to change those. So let's say we want to change 42. We double check. Does 90 minus 42 equal 48? And it does. So I can change sine of 42 to be cosine of 48. So I just used the complementary angles theorem here. Well, cosine 48 minus cosine 48, anything minus itself is 0. And that is 8. Okay, so again, I want you guys to try 9 on your own, see how you do, and then come back and check your work on mine. Okay, so first thing I would do is try and get them to be the same angle measure. So let's say we switch the 70. I'm just going on the idea that maybe you guys are always picking the first one to change, but either one that you change, you should still get to the same answer. So 90 minus 70 does get me 20. So I'm going to rewrite this 1 minus cosine squared 20 plus sine squared 20. Okay, so here is where a lot of you guys might be tempted to think that, cosine squared anything plus sine squared anything is 1. But you would be incorrect. The reason is because it's not cosine squared 20 plus sine squared 20. It's negative cosine squared 20 plus sine squared 20. So that is not the same as the Pythagorean identity. However, we are going to use that. So what I am going to do, I'm going to write the Pythagorean identity here. So sine squared theta plus cosine squared theta equals 1. And if you ever see me, instead of using theta, use x's. I do that a lot. Same, but different. So what if I were to get sine squared theta by itself? So what if I were to get sine squared theta by itself and move this over? That would get me 1 minus cosine squared theta. Now, do we in our problem see 1 minus cosine squared? And we do. So I can rewrite this. I know that 1 minus cosine squared 20 is actually going to be sine squared 20. Ooh, and this one doesn't end all nice and pretty like the other ones, which a lot of yours aren't. So be prepared. So sine squared 20 plus sine squared 20, they're the same thing. So all it is there's just 2 of them. So we would write that as 2 sine squared 20. So I'm going to explain my steps here. So I first use the complementary angles theorem, and then I use the Pythagorean identity here. So I used this to help me here. Okay, so now we are starting in 9 through 12. They aren't going to be all 1 or 0. So what I want you guys to do, I want you guys to try 10. Remember, it's not going to be 1 or 0. but I still want you guys to try it on your own. So try 10, pause me here, see how much you can get through, and then come back when you're done. Okay, so right off the bat, we recognize there is not even an angle measure. So we can't, like, they are the same angle measure at this point. So we're not going to be using the complementary angles theorem. There is nothing squared, so there's nothing we can do there. But we can write secant in terms of cosine. So we're going to keep sine theta the same. And then I'm going to write secant as 1 over cosine. Well, unlike all the others, there's nothing I can cancel here. So I just write it as sine squared or sine theta over cosine theta. And what do I know that sine over cosine is equal to? Tangent. So that's my final answer. That's as simplified as I can get. So I first used my reciprocal identity. And then I multiplied those together. And so to get from here to here, I then used my quotient identity. And that is your final answer for 10. These are more of like the types of problems you would see in like honors pre-calc and stuff like that. So you see it more like less equal 1 or 0 and more equal to an actual like another trig function, just simpler. Okay, so I'm going to do 11 with you. If you guys want to try it on your own, great. If you don't, that's fine too, but we're going to do this one together. So right off the bat, we know we're not going to be using a complementary angles theorem, but we are going to convert everything in terms of sine and cosine. So cosecant, I'm going to write as 1 over sine theta. Minus cotangent, I'm going to write as cosine theta over sine theta. And then cosine is already in terms, but I'm just going to write it over 1 so I don't get confused. Well, 1 minus sine, there's nothing I can do here. But cosine theta times cosine theta, that's like x times x, which gets me x squared. So cosine theta times cosine theta is cosine squared theta. And then sine theta times 1 is just sine theta. Now they have a common denominator. The common denominator is sine theta, so I can just write it as 1. 1 minus cosine squared theta over sine theta. Okay, now I have a squared in there. So what I'm going to do is I'm going to write my, well, I have it actually up here. So I'm going to use that Pythagorean identity and manipulate it. Well, wait, 1 minus cosine squared theta, 1 minus cosine squared theta is going to be equal to sine squared theta. And then sine squared theta over sine theta, this is the same as if you were to think about x squared over x. X squared over x would simplify to be x, right? So sine squared theta over sine theta gets me sine theta. That one's a little bit more of a doozy, but those are the ones I like. So those are a little bit more fun, I think. Okay, try 12. I want you guys to try 12. It's a little bit, it's, a little bit challenging like 11, but I think you guys can do it. You got this. So pause me where you're at and then try it on your own and then come back and check your work. Okay, so you should be coming back to check your work. I am going to start by writing everything in terms of sine and cosine. So cosine theta plus sine theta, none of these need to change, but tangent is going to be sine theta over cosine theta, and then I'm going to put this over 1. I'm also just going to, since we're dealing with fractions here, I'm going to write that one as 1 over 1 too. So cosine theta over 1 plus sine theta times sine theta, just like x times x, is sine squared theta. And then 1 times cosine theta is cosine theta. Okay, So here is where it gets a little different, right? So before over here, we had a common denominator, so I could just combine it and write it. But here, I don't have a common denominator, so I can't. Well, what would be the common denominator between 1 and cosine theta? Well, if you're saying cosine theta, you would be correct. So if I multiply top and bottom by cosine theta times cosine theta is cosine squared theta over cosine theta plus sine squared theta over cosine theta. And now they have a common denominator. And so we can rewrite it cosine squared theta plus sine squared theta over cosine theta. And now I'm thinking, okay, well, so I just combined the top and wrote it as 1. And now that I have the common denominator, I can write it as 1. Now I'm thinking, okay, well, I have my squares in there, so I want to use the Pythagorean identity. Well, we know the Pythagorean identity is sine squared theta plus cosine squared theta is equal to 1. Well, if I flip those around, they're adding, so we can do that. Cosine squared theta plus sine squared theta is also equal to 1 over cosine. And what do we know that 1 over cosine is the same as? Secant theta. So that whole thing simplifies to be secant theta. And that is your final answer. And that is it for our trig identity examples. Again, like I said, I really encourage you guys, bring your questions to office hours. I'm super happy to help you guys with these. I love these. I nerd out on these completely. So, let me know if you guys have any questions, you need any help with them. I'm happy to help you guys. So I hope you have a great day, and I will see you on the next video. Bye, guys.